Let's go ahead and talk about solving equations quadratic in form. What does that mean, quadratic in form? If you remember, a quadratic equation is ax squared plus bx plus c is equal to 0. In this case, the fact that the highest power is 2 makes this a quadratic equation. So what we have in front of us right now, the 3x to the fourth minus 2x squared minus 1 equals 0, it is not a quadratic equation, but notice the resemblance between what we have as a quadratic equation and the one on the left-hand side. This is what is referred to as quadratic in form. It kind of looks like it could be a quadratic, and so what we are going to do is a technique to be able to rewrite this problem as a quadratic equation. The reason being that then we can use factoring to try to solve it. And that method is called substitution. We are going to let u equals x squared. By letting u equal x squared, we are now going to substitute this into the equation that we have in front of us. So the 3x to the fourth becomes 3u squared because u squared means x squared squared, which is x to the fourth. So what we are doing is using substitution to take what we see in front of us, which has the highest power of 4, and rewrite it as a quadratic that we can easily solve by factoring. So now I'm going to keep going, and I'm going to say minus 2 instead of x squared. Since x squared equals u, I'm going to write minus 2u minus 1 equals 0. So now I can go ahead and solve this. This is just factoring a trinomial where the leading coefficient is not equal to 1. So I'm going to take the 3, multiply it to negative 1, and I'm going to end up with negative 3. What multiplies to give me negative 3? That's going to add to give me a negative 2. That is negative 3 times a positive 1. If you still need more practice with factoring, I would suggest that you watch the videos that I have on each different type of factoring. In this case, this type of factoring is factoring when the leading coefficient is not equal to 1. I'm going to go ahead and put the link to that video down in the description below. So then here, I'm going to go ahead and rewrite this as 3u squared minus 3u plus u minus 1 equals 0. Now that I have 4 terms, I can factor by grouping. From the first group, they both have a 3u in common. I'm left with u minus 1. From the second group, there's nothing else that I can take out, so I'm going to factor out a 1 as the greatest common factor, the GCF. Now they both have u minus 1 in common, and I'm left with 3u plus 1 is equal to 0. According to the zero product property, I can take each one of these factors and set it equal to 0. Because if you multiply two numbers together and the answer is 0, one of them has to be 0. I get u is equal to 1. I get 3u is equal to negative 1, which makes u equal negative 1/3. Now you have to be careful because those are not the answers to this problem. We are still trying to solve for x, and if you remember, we let u equal x squared through substitution. So if u is equal to 1, that means that x squared is equal to 1 because remember, u is equal to x squared. We decided to substitute at the very beginning of the problem. And so by the square root property, I can take the plus or minus square root of 1. So x is equal to plus or minus 1. So that means that so far I have x equals plus or minus 1 as 2 answers to this polynomial equation. Let's go ahead and continue to find the other 2 answers. So if u is equal to negative 1/3, I'm going to substitute x squared for u. I'm going to go ahead now and take plus or minus the square root of both sides. The square root of negative 1/3, this is going to take a little bit of work to simplify because the square root of negative 1 we know is I. So x is equal to plus or minus I all over the square root of 3. I don't want to be left with a radical in the denominator, so I have to rationalize, which means I'm going to multiply top and bottom by the square root of 3. So I end up with x is equal to plus or minus the square root of 3i all over 3, because when you multiply the square root of 3 times the square root of 3, it becomes the square root of 9, which of course is just 3, and that's what we put right here in our answer. So this right here are my other two answers. So either x is equal to plus or minus 1, or x is equal to plus or minus the square root of 3i over 3. And notice this is a polynomial equation. Because the highest power is 4, I knew that I was going to have 4 solutions to this problem. Let's go ahead and take a look at another problem where we're going to apply this idea of substituting so that we can rewrite these quartic functions as quadratic equations that we can easily solve through factoring to make our lives a little bit easier. So I'm going to start by using substitution. Let u equal x squared. And you might be thinking, why u? Yes, u is used a lot in mathematics for substitution all the way up to calculus. Okay, if you eventually take calculus, you will see that it is very common to let u be something that we're going to substitute to make our problem easier. So after deciding that u is going to equal x squared, we're going to substitute. So we get u squared minus 8u minus 9 equals 0. This one is much easier since it is factoring a trinomial and the leading coefficient is equal to 1. So what multiplies to give me negative 9, that's going to add to give me negative 8. So that's easy, negative 9 times a positive 1. I'm going to go ahead and write u plus 1 times u minus 9 is equal to 0. By the zero product property, that means either u plus 1 equals 0 or u minus 9 is equal to 0. If I subtract 1, I get u is equal to negative 1. And if I add 9, I'm going to go ahead and get u is equal to 9. But we have to remember, we really are not solving for u. We are solving for x. So that means that we have to go back and substitute again. If u is equal to negative 1, then that means x squared is equal to negative 1. And if I take the square root of both sides, I am going to get plus or minus I as two of my possible answers for this problem. If u instead is equal to 9, that means x squared is equal to 9. So x equals plus or minus the square root of 9, x equals plus or minus 3. So again, this is a 4th degree polynomial. I was expecting to have 4 solutions, and here they are. The solutions are positive 3, negative 3, positive I, and negative I. There are 4 solutions to this problem, just like in the previous one. This concept of solving equations quadratic in form can be applied to situations like the one in question number 3. Notice that what we have instead of a 4th degree polynomial is simply x minus 5 in parentheses, and we see that this is carried over in both the quadratic term and the linear term. So I actually can sit here and multiply everything out and combine like terms so that I can have a simplified problem, or I can apply the technique, which is what this video is about, where you're going to allow substitution to simplify this problem into a quadratic equation. So in this case, we're going to let u equal x minus 5. And that means that u squared minus 4u minus 21 is equal to 0. I can once again solve this by factoring. What is going to multiply to give me negative 21 that is going to add to give me negative 4? It's going to have to be positive 3 times negative 7. Negative 7 times positive 3 is going to add to give me negative 4 and multiply to give me negative 21. So I get u minus 7 times u plus 3 is equal to 0. According to the zero product property, that means either u minus 7 equals 0 or u plus 3 is equal to 0. So we get u is equal to 7 or u is equal to negative 3. Once again, those are not our final solutions because of the substitution. This means that if u is in fact equal to 7, then x minus 5 equals 7. So if I add 5 to both sides, x is actually equal to 12. On the right hand side, if u is equal to -3 and u is just x minus 5, that means x minus 5 is equal to -3. So if I add 5 to both sides, I get x is equal to 2. So my two solutions are the numbers 2 and 12. And I expected there to be two solutions because this is a second degree polynomial. The highest power is 2. Another way to do this problem is to go ahead and multiply everything out. So if I take x minus 5 squared and I distribute, I know that this part right here is going to end up giving me x squared minus 5x plus 25, which is x squared minus 10x plus 25. If I take the middle part, -4 times x minus 5, and I distribute, I get -4x plus 20. So if I put this all together, I'm going to have x minus 5 squared minus 4x minus 5 minus 21 equals 0. But we know that x minus 5 squared is just x squared minus 10x plus 25. We also know that this part right here, the -4x minus 5, is simply -4x plus 20 minus 21 equals 0. So now I can go ahead and combine like terms. I'm going to get x squared, -10x, -4x is -14x. Positive 25, positive 20 is positive 45. 45 minus 21 is positive 24. And this is all equal to 0. Now I have to think about what's going to multiply to give me 24. That's going to add to give me -14. And so that's going to be -12 times -2 equals 0. So I get x is equal to 12, x is equal to 2. So notice that this is the same answer that we got when we used the process of substitution to go ahead and simplify this problem, which is quadratic in form. Hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.